is based on kind of very dry climate, dry biome. But quite interesting because we haven't seen many of these fires in this part of the world.
But
yeah. So here we present a new method to forecast the fire danger. It uses machine learning method to combine a lot of information, not only weather, but also fuel in terms of availability and dryness, and most importantly, source of ignitions. So where people live, road access to places. This is a substantial advancement on what was done before, because previous method only used weather. So you see, I mean, it's quite, it looks quite much better than the classical FWI.
And it's interesting that we've got the high risk actually over desert regions where we don't have any fuel at all. And actually the real risk that we see in the machine learning model is in a different location. It's where actually a lot of the fuel exists, but there's also those weather conditions required for the fire.
This is clearly not an information that is clearly not available for the standard fire weather index.
Yeah, because you can see on the circles and the triangles where we actually observe the fires, it's very much more in line with this model.
This is really good prediction.
So historically for fire forecasting we use what's called the fire weather index, and this is a simple physics-based model where we use 4 weather variables: temperature, wind, precipitation and humidity, to forecast the chance that if a fire does occur how intense it will be. So what we know from that is that it doesn't account for a lot of things. It doesn't account for fuel, it doesn't account for ignition sources and things like that. So what we try to do here is we try to incorporate more data into a machine learning framework. So although a lot of this data can't be explained physically, we can use machine learning to get a better forecast using that data without the knowledge of the physics underlying it. So we incorporate fuel, ignition sources and also the existing weather that we previously used in the machine learning model to predict not just fire danger but the probability that a fire might occur in a given location.
I think machine learning can be a very effective way to merge together different kind of information. Traditionally, I mean, physical model are able very well to... Yeah, for example, recent case in Los Angeles where fire really broke out in the wildland-urban interface. This was really very severe because the previous season were actually characterized by very wet conditions, which created an abundance of fuel that then was burned during the event. And of course, this new method, the probability of fire, having the memory of the fuel abundance in their formulation, allow to really identify those regions that could be much more affected compared to simpler method that only consider weather. And this is why our prediction in this case was much more precise and pinpointed the exact location when very close to Los Angeles where fire really occurred.
Yeah, so the purpose here is to try and produce a cost-effective piece of machinery that people can take away and use. So it's very expensive maybe to train, but once we've trained the model here using our high processing computing power, other centres can then take it and run it very cheaply, and they can run it on their local laptops, for example, with very little cost. So I think the machine learning really helps with getting the more precision on the location of where a fire might occur. And this is relevant for agencies involved in suppression activities, because then they can allocate resources into the locations where the fire might actually occur, as opposed to just a widespread warning system that currently exists. In some ways it's a step change in fire forecasting, because we're really going from suggesting where fire danger might happen, where there's the potential for fires to exist, to saying this is where we think fires will actually exist. And for that reason, it's quite a large leap forward, I think, in terms of fire forecasting.